Hello guys, it is Mr. Mitchell again with another video about National 5 Chemistry. Today we are looking at titration calculations. Now before we get into actually figuring any calculations out, I want to have a little talk about what is a titration, okay? Now you guys may or may not have done a titration before, but in titrations what we are looking at is combining two chemicals together. Now, more specifically, what we are looking at is acids and alkalis. Okay, so the first thing we need to know is what do we make when we combine an acid and an alkali? Well, you were taught it in second year and we've already gone over it in this topic. When you combine an acid and an alkali together, you always make a salt and water. Okay, so we are going to be looking at different combinations of acids and alkalis today, and we are going to be looking at the salt that they make plus water. Okay, and what we are doing with titration calculations is we are normally trying to figure something out about either the acid or the alkali here. Now we can either figure out its concentration, we could figure out its volume, okay, and they are usually the two things that we'll be looking for to figure out. Okay, so it might be a case of they give you the concentration and volume of the acid and they only give you the volume of the alkali and they ask you to figure out the concentration, or they want you to figure out the volume of the acid that you would need to add in, or they would want you to figure out the volume of alkali that you need to add in. Okay, so they're going to be asking you for either concentration or volume here. Now we have already looked at concentration and volume using a triangle, okay, where we had N, C, and V, okay. N stood for the number of moles, C stood for concentration, and V stood for volume. Now we are going to use these two, again, concentration and volume, but we're not actually going to be using N in the same way today. Now that N there means number of moles. Okay, we should all be quite happy with that. We are going to use the letter N today, but we are going to use a capital N, okay, which is actually different from the lowercase n. Now this N here means something slightly different, and we're going to look at what that means in a second just now. So just to recap what I've said there, we're looking at titration calculations, which is all about acids and alkalis being combined together, okay, and we are going to be figuring out concentrations and volumes for these combinations of the acids and the alkalis. Okay, let's have a look at some. Now we have a few steps when we are doing titration calculations, and what I would like you to do is I would like you to copy down all of the examples that we are doing, okay, and I want you to put the steps next to them. So our first step here is to write the balanced equation. Now we have an alkali here and an acid here. We've got sodium hydroxide and hydrochloric acid giving us sodium chloride and water. So there is our alkali, there's our acid, there's our salt, and there's our water. Okay, so your first step is to write the balanced equation. Now what we would do is we would check that equation was balanced, and how we would do that is with our usual method of our writing what elements are present and checking to see how many there are. So how many sodiums we have on that side, we've got 1. How many do we have on that side? We've got 1. How many oxygens? 1. How many oxygens? 1. How many H's? 1. And we've got, no, sorry, we've got 1, 2 on that side. Ignore me. And we've got 2 on that side. We've got 1 and 1. So, lucky us, it's completely balanced. So we don't even need to do anything with that. It is nice and balanced for us. So the first step is to write your balanced equation. So make sure you've got an equation, make sure it's balanced. Then what we're going to do is we are going to introduce the titration equation below it, and we are going to state the acid and alkali, and you'll see what I mean in a second here. So this right here is our titration equation. This C1 V1 over N1 equals C2 V2 over N2. Now what we are doing is we are saying here that anything with the letter 1 is talking about our alkali over here, because our C1 V1 over N1 is below our alkali. Anything that's talking about 2 is our acid, because that one's below our acid. Okay? And we're going to have a look at what these letters mean here. So C still means concentration, V still means volume, okay? But this time N doesn't mean number of moles. The N in this one, so the N's here, actually are the number in front, okay? What we call the coefficient. So for example, with both of these ones, there is no number in front of it, so N will be 1. Okay, if we had, for example, if we had the number 2 there, N would be 2 when we are putting all of our numbers in. Okay, we will practice ones that have numbers in front of them, so don't worry about that. You will see plenty of examples. What I want you to do just now is to pause this video and make sure you have this entire slide in your jotter before you move on. Okay, so pause the video here, make sure you've got all of that down. Okay. Now one thing I will say is this method that we are doing to figure out this titration equation is actually one of 2 different methods. Now I am showing you this method, but Dr. Adil is also doing a video of the exact same slides with the exact same questions using another method. So if you watch this video and think, whoa, I have no idea how to do this, go and watch her video and see if you understand her way of doing it better. Now, before we move on to an example, one thing I just want to highlight is this equation here, okay? If you forget this equation, you can find it in your data booklet, okay? It is on the first page of the data booklet, right here. So if you do forget it, that's it there, okay? Just remember that the N here, though, isn't the same as that N or that N, okay? It doesn't mean number of moles, it's talking about the number in front of the formula. And that is why our first step is our balanced equation, so that we get all of our numbers right. Because if we don't balance the equation, our N's won't be correct. So to get ourselves more familiar with this equation and with the sort of questions that you'll be dealing with, what I'm going to do first is I'm going to show you one on the PowerPoints, and then we're going to go on to doing some more worked ones together. So here is a classic example of a question you would be likely to get, okay? It says, if 20 centimeters cubed of 1 mole per litre sodium hydroxide is used to neutralise 30 centimeters cubed of hydrochloric acid, what concentration was the hydrochloric acid? So, and it gives you an equation here as well. It may not always give you the equation here, by the way, which isn't a problem at all for us, because we know how to make these equations and we know how to do formula. So we are actually totally fine, even if it doesn't give us this. But what I want you to focus on first is this question has got a lot of numbers in it, and it's got a lot of different words and formulas in it, okay? Don't let that scare you. Don't let it scare you off. All you need to do is break it down, and we have lots of ways that we can make this more simple for us. The way in which I want you to lay this out helps make this question a lot easier, okay? So I'm going to show you how I want you to lay it out. What I want you to do is I want you to write down the equation, okay, like you would normally do whenever you're doing a question. And what I like to do is I always put a big line down the middle of my paper. Now on the right hand side of this line, I write all the things I know from the question, and on the left hand side of the line here, I will actually write down the calculation using the equation. So the first step that I want you to do is I want you to draw the line in the middle of your paper, and I want you to write C1 V1 N1 C2 V2 N2. Now C1, V1 and N1 stand for the concentration, the volume and the coefficient in front of this first value here. It's C1, V1, N1 because that is the first thing, okay? And you can see here that C1, V1, N1 are right below this formula right here for our sodium hydroxide, okay? That is not a coincidence. C1, V1 and N1 are all relating to what is above it, okay? The exact same thing is for your C2, V2 and N2. C2, V2, N2 is talking about the concentration, the volume and the number in front of your HCl here, your second thing, okay? So in this example, our C1, V1, N1 is talking about our alkali and our C2, V2, N2 is talking about our acid. Now in actual fact, it doesn't matter which way round you write these and which one is 1 and which one is 2. It doesn't matter as long as you keep one of them 1 and one of them 2 the whole way through, okay? As long as you don't switch them halfway through, it doesn't matter which one is which. So, like I was saying before, this question has a lot of information in it that we need, okay? So I would recommend that you would write the C1, V1, N1, C2, V2, N2, and then write what C1, V1, N1 actually are. So our C1, V1, and N1 are talking about our concentration, volume, and our coefficient in front of our NaOH. Now we know that from the question that we have 20 centimeters cubed of 0.1 mole per litre NaOH. So we know that the volume is 20 centimeters cubed, which is here, okay? And we know that we have 1 mole per litre, which is a concentration, which is here. We also know that the number in front of there is an invisible 1 because remember in chemistry we don't like to write ones. So we know that that value is 1. You will also notice that these are in blue because these are talking about an alkali, and these ones are in red because they're talking about the acid, okay? This is the alkali, this is the acid, okay? So our blue is our alkali, our red is our acid, and we've got blue and red. Now, the question also tells us that we have 30 centimeters cubed of HCl, okay, which is why that red one is here, okay, because our HCl is our red, our acid, and we know that 30 centimeters cubed is a volume. We can also figure out the N2 because it's got nothing in front of it, which means the N2 would be a 1, and that's why the 1 is here, okay? Now, the piece of information it hasn't given us that it asks us to figure out is what the concentration of the acid is. Now, this is a relatively straightforward to figure out. All you have to do is put all the numbers that are over here into this equation here. Okay, now if you do that, it would follow along like this. Okay, so if you put your C1, which is 1 there, your V1, which is 20, is there, N1 is 1, which is why that's there, your C2 you don't know, so you would just put C2 in there, your V2 is 30 because you know you've written all these down already, you've got yourself ready, and your N2 would be 1. If you do 20 times 1 divided by 1, you get 20, and if you do 30 divided by 1, you get 30. Anything divided by 1 is just itself, so that's why you can basically just get rid of the 1s. So you know from this that 20 equals C2 times 30. Now to get rid of that 30 and just get C2, you have to divide both sides by 30, which is what's happening here. So 20 divided by 30 is what C2 would be, which is 0.66 moles per litre. Now what I want you to do is I want you to take a note of this question, this equation, I want you to draw the line, and I want you to write everything that is on this slide in your jotter before we move on to some worked examples of these, okay? I want you to have a complete template on how to do these. We are then going to work through some examples together, and I'm going to show you how to do them, how I would write them out, which is just like this. We're going to do 5 of them together, and then we are going to set you some questions to try them on your own, okay? So pause this video and take a note of that before we move on. The next thing we're going to do is we're going to have a look at some examples. Now, I have taken the examples the 5 examples from the slide, and all I'm going to do is I've put them into OneNote here, okay, just because it gives me more room to write. They are the exact same ones that are on the slides, so don't be worried, don't think they're anything different. You'll see I've just literally copied and pasted them from the slide, that's why they're still green. Now, what I have done for this first one is I have already done step 1. I've made sure the equation's balanced. I checked it using our traditional method of the elements below. I'm checking that there's the same amount on the left as there is on the right. So what I would like you to do is I would like you to take a note of this question and write out the balanced equation and show that you've checked it like I have. So take a wee second to do that just now. You can pause the video and then unpause it, and we will start going through the question. Okay, so in this it says, in a titration calculation, 10 centimeters cubed of 2 mole per litre sodium hydroxide solution was neutralised by 25 centimeters cubed of dilute hydrochloric acid. And it asks us to calculate the concentration of the acid in moles per litre. So we've already got a balanced equation. We know that it's correct. What our next step is going to be to do is to write out the titration equation. So that is our C1 V1 N1 equation. So I'm going to do this in black, I think. So C1 V1 over N1 equals C2 V2 over N2. And what I'm actually going to do just now is I'm going to put a line right down my page there, okay, to separate the next part. What I like to do is I like to set these up in a certain arrangement just to make it clear for myself what I'm talking about, okay? And I'm actually going to color code these as well. I am going to put the alkali in blue, okay? So that's my alkali there. I'm going to put my acid in red. So if I'm talking about my alkali, that would be C1, V1 and N1, okay? And we're going to write down what we know from the question. If I'm talking about my acid, that will be C2, V2 and N2. So from this question, what do we know about our alkali, about our sodium hydroxide? Let's go and have a look. So it says we have 10 centimeters cubed of 2 mole per litre sodium hydroxide. So we know that its volume is 10 centimeters cubed, and we know that its concentration is 2. So concentration of 2 moles per litre and a volume of, what was it again? 10 centimeters cubed. Now we can also say what our N is, because there is no number in front of that there, which means it is 1, okay? And we can do the same for our acid. We know that's a 1 as well. Now what did it tell us about the acid in the question? It told us the volume, so we can also put the volume for our acid into our, so there we go, 25 centimeters cubed. And it asked us for the concentration in the question, so I'm going to put a question mark there. So that's us got everything from the question written out for us to then place in our titration equation when we want to use it. So just to make this super duper clear, all of this stuff here is our sodium hydroxide, and all of this stuff is our hydrochloric acid. So what we're going to do now is we're going to put all of the values into our lovely equation that we have here. So do we know what our C1 is? Yes, our C1 is 2, so it'd be 2 times V1, which is 10. So 2 times 10 over N1, which is 1, equals C2. Now we don't know what C2 is, so we're just going to put C2 times V2, which is 25, divided by N2, which is 1. So let's figure out all the things we can first. So 2 times 10 is 20 divided by 1 is 20, sorry. So that would be 20 there. In fact, I'm going to change that to be blue. And we know that C2 times 25, we can't figure that out yet, but all of that divided by 1 will still be C2 times 25. So what we want to figure out is, what is C2? Now to figure that out, we need to get rid of this 25. And the only way that you can get rid of this 25 is to divide this side and this side by 25. So C2 would equal, sorry, wrong pen, would equal 20 divided by 25, which should give us an answer of 0.8 moles per litre. Now, I want you to make sure that you have got all of that written down in your jar. You can colour code it if you want, like I did, but you don't have to, okay? So make sure you've got that entire example in your jar before we move on to the next one. Example number 2, and it says, in a titration 25 centimetres cubed of 2 mole per litre sodium hydroxide solution was neutralised by 28.7 centimetres cubed of sulfuric acid, and it gives you the formula for both of them there. Then it asks us to calculate the concentration of the acid again. So we're doing the exact same steps, we are just using a different acid this time. Now if we're using a different acid, that means we have a different equation, okay? So for this one, we know that we're using sodium hydroxide, so let's write that again. We know that we're using sulfuric acid because it tells us there, and it gives us the formula for it, which is H2SO4. And we also know that we will make a salt and water. Oh, I'm writing water. What is the formula for water? H2O. Now, in second year, and previously in this topic, you learned how to name salts, okay? So you know that sodium hydroxide and sulfuric acid combined together should give you sodium sulfate. Yes, you should know that. So what we're looking for here is the formula for sodium sulfate. Now, we can't just write the word sodium sulfate there because this isn't an equation then. This is a word in here and it's not a chemical equation. So what we need to do is we need to find out what sodium sulfate is. And the best way that we can do that is using our SVSDF. So let's write that down, SVSDF. Now S stands for symbol. The symbol for sodium is Na. The symbol for sulfate, now we can find sulfate because it ends in 8 on page 8 of our data booklet. So let's go find it. Here it is here. So this is the table that you're looking for, and sulfate will be in this table. Let's get it all, there we go. So you need to look into this table and you need to find sulfate. Now sulfate is here, which is SO4 2 minus. Wrong way. So it's SO4 2 minus. Next step is the valencies. Now you can find your valency of your sodium from the periodic table, which I'll just go back and remind you of. So let's find sodium. Sodium is there. It is in group 1, which means it has a valency of 1. So we write a 1 there. Sulfate's valency you get from its charge here. So it's got a charge of -2, which means its valency is 2. So we've got symbol, valency, swap, divide. You cannot divide them to make them any simpler. And then formula. And in the formula you just combine them. So it'd be Na2SO4. And you don't need to include the charge in the final formula there. So what we can do is we can actually just get rid of that there now. And we now know that it is Na2SO4. Perfect. So our next step is to take this equation and make sure that it's balanced. Okay, so this is actually really just our first step still. So let's make sure this is balanced. Let's write it out again. So we've got sodium, we've got oxygen, we've got hydrogen, and we have sulfur. Okay, so sodium, oxygen, hydrogen, hydrogen again, sulfur, and oxygen again. So how many sodiums do we have on this side? We've got 1. How many do we have on this side? We have 2. How many oxygens do we have on this side? 1, 2, 3, 4, 5 on this side. And we have 1, 2, 3, 4, 5 on that side as well, which is good. We have 1, 2, 3 hydrogens on that side, and we only have 2 on this side. We have 1 sulfur on this side and 1 sulfur on that side. So we've got to try and balance our equation now. We know that we're going to start off with our sodium. We've got 1 on this side and we've got 2 on that side, so we want this to be a 2. To do that, we could put a 2 in front of here. That would change that to being a 2. It would also change our oxygen, our hydrogen though. It would give us 1, 2, 3, 4, 5, 6 hydrogens now. And 1, 2, 3, 4 of our hydrogens there. Okay, so our sodiums are balanced, but now our oxygens aren't. So to balance our oxygens, we just need 1 more. Now if we put a 2 in front of the water there, that will change that to 1, 2, 3, 4, 5, 6 oxygens. It will also change the hydrogens though, so that will give us 4 hydrogens on that side, and it doesn't affect this sulfur, so we've still got 1 there, which means that solves our problems for us, and this is now completely balanced. So we've got ourselves a balanced equation now. That is step 1 complete. Step 2 is to then do our titration calculation. So I should really write that down. So titration equation, and let's just rewrite this balanced equation just to make sure that we know what we're talking about. So 2 NaOH plus H2SO4 gives us Na2SO4 plus 2H2O. Okay, now what we're going to do next is we are going to write down the titration calculation, which is our C1 V1 over N1 equals C2 V2 over N2. Now notice I've got one of them below my alkali, one of them below my acid. I'm going to draw that line again. I'm going to write what all of our C, V's and N's are, and I'm going to colour code them again like I did last time. So C1 V1 N1 C2 V2 N2. So let's look back at the question now and figure out what we know. So from the question, what does it tell us about our alkali, our blue one? So it says we have 25 centimeters cubed, which is a volume, and it tells us the concentration of our alkali as well. So we know the concentration is 2 moles per litre, and we know the volume is 25. Now we can also figure out the N as well. It has a 2 in front of it, which means that it is 2 there. And all of this here, remember, is talking about our sodium hydroxide, our NaOH. In red, we're talking about our acid here. Now we know that Rn is going to be 1 because there's no number in front of that. Do we know our concentration? Do we know our volume? Let's go and check the question. Now it's asking for the concentration. It's asking for the concentration here, but it does give us the volume of 28.7. So let's put 28.7 centimeters cubed in there, but we don't know the concentration. That's what it's asking for. So we'll put a question mark in there. Remember, all of this in red here is all talking about our sulfuric acid there, our H2SO4. So let's put all of these values into this lovely equation here. So C1 is 2, V1 is 25, and N1 is 2. We don't know what our C2 is, so we've just got to put C2 still. We do know our V2 is 28.7, and our N2 is 1. So let's go through that and figure that out a little bit more. So 2 times 25 is obviously 50, divided by 2 is still then 25. So that would end up being 25. And C2 times 28 divided by 1 is still just C2 times 28. Okay. So if we now want to figure out what C2 is on its own, without the 28, what we have to do is we have to take both sides and divide them by that 28.7. Okay, so C2 equals 25 divided by your 28.7, which should hopefully equal 0.87 moles per litre. That should be the final answer for that one. So what I want you to do is make sure you've got all of that down. If you need to pause the video or if you need to go back and take any notes or anything, please do before you move on to the next one. Right, example number 3. Let's go. It says, in a titration, 20 centimeters cubed of potassium hydroxide, which is KOH, solution was neutralized by 42.6 centimeters cubed of 0.5 mole per litre hydrochloric acid, which is HCl. This time it asked us calculate the concentration of the base. So in the last two it asked us to calculate the concentration of the acid. This time we're going to calculate the concentration of the base. Now it's pretty much the exact same thing, just with a slight difference. You are using the exact same equation in the exact same way, so don't worry about that at all. What we want to do first, remember, is our very first step is we want a balanced equation. Okay, so step 1 is our balanced equation. Now, some of you may be thinking, how on earth do I do that with the information I'm given? Don't panic. It is actually probably a lot easier than you think it is. Use what you're given in the question. So potassium hydroxide, it tells you it is KOH. So we're going to write KOH plus our HCl. That is our alkali and our acid. They combine together to give us a salt and water. And we know that water is H2O. You should also know that from second year, like I said before, potassium hydroxide and hydrochloric acid, when they combine together, they would give you potassium chloride. Okay, so we know that will give us potassium chloride. Now we've got the name, So all we need to do is our SVSDF to figure out its formula. And let's do that now. So SVSDF. So S stands for symbol, potassium symbol is K, chlorine symbol is Cl. The valencies, remember, you can find from the periodic table. So potassium is K, which is down here. It's in group 1. Its valency is therefore 1. Chlorine is in group 7, okay, which means its valency is also 1 because it's 1 away from 8. Remember, it would gain 1 to become stable, so its valency is 1. Okay. We swap them, stays as 1 and 1. Can't divide them to make them any simpler because it's 1 and 1. So therefore it is KCl, which is actually very nice and convenient for us. So let's just rub that out and let's put it in because we now know it. So KCl. Our next step is to make sure that it's balanced now that we've got everything there. Okay, so I'm going to rewrite it and make sure that it's balanced. So we've got potassium there, we've got oxygen, we have got hydrogen, and we've got chlorine. So we've got 1 potassium on the left, we've got 1 on the right, got 1 oxygen on the left, we've got 1 on the right, we've got 2 hydrogens on the left because we've got 1, 2, and then we've got 2 hydrogens on the right because it's H2O. We've got 1 chlorine on the left and 1 on the right. So brilliantly for us, that is already balanced, so we don't need to do anything with that whatsoever. Let's make ourselves some more room here. So we've got ourselves a balanced equation. We've done step 1. Our step 2 now is to use the titration equation. So let's write out our full equation again, just so we don't get ourselves confused. So it's KOH plus HCl gives us KCl plus H2O. Sorry. Okay. Now I'm going to give myself quite a bit more room here. There we go. Let's move that out of the way. Again, I'm going to draw my nice line down the middle that will separate what's going on here with our titration equation, and we're going to write down here all the things we know. So again, we're going to put our C1, V1, N1, and then our C2, V2, N2. And we're going to put our titration equation in. C1, V1 over N1 equals C2, V2 over N2. Now let's write down what we've got from the question. So our question here says 20 centimeters cubed of potassium hydroxide. So let's have a look. Potassium hydroxide is our 1, and we know we've got 20 centimeters cubed of that. So let's write that in there. We also know its N value is 1, but we don't know the concentration. Let's have a look and see what we know about our acid. It tells us that we have 42.6 centimeters cubed, so that's the volume, and it tells us the concentration of that is 0.5. So that is 0.5 and 42.6 centimeters cubed, and that is in moles per litre. Okay, we also know one last thing from this equation here. We know our N2 is also 1. So remember, all of that stuff there is talking about your HCl, and all of this stuff here is talking about your potassium hydroxide, your KOH. Our next step is we just have to put the numbers into our equation like we did before. So let's start off with our ones in blue, our C1. We don't know what C1 is, but we do know what V1 is. That's 20. and we do know what N1 is, that is 1. For our two values for our acid, we know them all this time, so that would be 0.5 times our 42.6, all divided by 1. And if you put those numbers into your calculator, you will find that for this side you will get 21.3, and for this side you will still end up with C1 times 20. Okay, so we want to figure out what C1 is, therefore we need to divide all of this by 20, that side and that side. So C1 will actually equal our 21.3 divided by 20, which should equal, hopefully, 1.65 moles per litre. And that will be your final answer. Take a minute to make sure you've got all of that down, including balancing the equation, etc., and then get ready to do the next one. Okay, this next question is again a little bit different, but we have to do all the exact same steps. First thing to do is read the question and figure out what it's asking for, and then we'll start going through it. So it says, in a titration, 2 mole per litre sodium hydroxide solution was neutralised by 22 centimetres cubed of 0.1 mole sulfuric acid, and it gives you their two formulas there. This time it's asking us to calculate the volume of the base that was neutralised. So it's not asking us for a concentration this time, it's asking us for a volume and of the base. So it's very similar to the last question, except for instead of calculating C1, this time we're going to be calculating V1, but we have to do pretty much everything the exact same up until that last step there. So our first step is to make sure we've got a balanced equation. So step 1 is still balanced equation. And we're very lucky, they've given us our equation, our formulas for our sodium hydroxide and sulfuric acid yet again. So NaOH plus H2SO4 gives us our salt and water, just like before. And again, we use the exact same method to figure out what that salt was. Okay, we know that sodium hydroxide and sulfuric acid, when they join together, should give us sodium sulfate. That is the salt that they will give us when they combine together. So what we need to do is we need to figure out, okay, well, what would sodium sulfate's formula be? Now, we are quite lucky, we have already done that in a previous question. Where is it? Sodium sulfate's there, Na2SO4. So I'm not going to go through these steps again here. I'm just going to write down this equation to save time. Okay, so we know that it's Na2SO4 for that salt there. Okay, we want to check that it's balanced. Okay, now we know from the previous question again that this is not the balanced equation. We know that we need to add some numbers into this to balance it. So again, I'm going to just look back up here and refer back to this question because we've already done it. So there was a 2 in front of your sodium hydroxide and a 2 in front of your water before. So make sure that it's balanced again. Okay, it needs to be balanced, otherwise your values for your N will be wrong and your entire calculation will be incorrect. So let's just check that it's balanced. We've got 2 sodiums, we've got 1, 2, 3, 4, 5 waters. No, we've not. We've got 6 waters. We've got 6 waters on that side. We've got 1, 2, 3, 4 hydrogens. We've got 1, 2, 3, 4 hydrogens. We've got 1 and 1 for our sulfur. So our first step done. We've got a balanced equation. Our step 2 is now to use the titration equation with that. So let's rewrite our equation again and start doing the calculation. Okay, I'm going to draw my line down the middle that separates all the things that I'm doing. I'm going to put the equation in, C1V1 over N1 equals C2V2 over N2. And again, I'm going to write my C1 equals V1 equals N1 equals. Now feel free to skip this bit and write it out later, whatever you want to do. You don't have to sit and watch this in real time. We're pausing it anyway, so feel free to ignore the little bits where I'm writing things down. I'm just going to go and find all these C1, V1, N1 and C2, V2, N2 from the question. So let's look at our sodium hydroxide ones first of all, and then we'll tackle our sulfuric acid ones. So what does it tell us about sodium hydroxide? It tells us we've got 2 moles per litre of it. That's all it tells us. So we know that we've got 2 moles per litre of it. And we know that N is 2, but we don't have that. We don't have the volume. That's what the question is asking for. It's asking us to calculate the volume. But we do know a lot more about our acid, so that's 22 and 0.1, 0.1 and 22. And we also know our N is 1 from that. So just like we did before, what we're doing is we're plugging all of these numbers into our equation here. So we know that C1 is 2, but we don't know V1. We know that N1 is 2. We know C2, V2 and N2 this time, which is great. So we can plug all of them in. And what I will do is I will just leave this side of the equation alone for the time being, and we will do this side first. Okay, so 0.1 times 22 divided by 1 should end up being 2.2. In fact, I'll just get rid of it. Okay. Now, on this side, we will still have our two times V1 over 2. So to get rid of these two here, we would have to times that by 2, times everything by 2 to get rid of that one, and then we'd have to divide it by 2 to get rid of that one, which is actually essentially undoing what you've just done. So in actual fact, V1 is equal to 2.2, and that's centimeters cubed. Okay. Now, if that little bit there's kind of confused you at all that I've done there is essentially 2.2 times by 2 and then divided it by 2. Now they cancel each other out, so it is just 2.2. Okay? But the final answer there should be 2.2. Make sure you've got all of that one down again, including the question, etc. And then get ready to move on to the next one. So we have our last but certainly not least question here. I'm just writing down step 1, balanced equation. Okay, so we're following the exact same steps as we did before, and this time again we are calculating the volume of the base. So this is the exact same method as the question we've just done. It's just using different acids and different alkalis. Okay, so what it says in this one is a titration of 0.05 moles per litre potassium hydroxide solution was neutralized by 17.1 centimeters cubed of 0.25 mole per litre phosphoric acid. Then it asks us to calculate the base, the volume of the base. So the first step we need is we need a balanced equation. Now we've got our alkali and we've got our acid here, so we're just going to write them down exactly as we have been doing before. So KOH is our potassium hydroxide, and our phosphoric acid is H3PO4. And we know they make a salt and water. Now, just like we did before, we need to figure out what the formula for that salt would be. Now, we should know that potassium hydroxide and phosphoric acid combined together give us potassium phosphate. So we are looking for potassium phosphate here. So we're going to need to use our SVSDF again to get the formula for that. Potassium is K, S for symbol, K. Now phosphate ends in 8, so it's on page 8 of your data booklet, so let's go find that. Oh, that was it there actually. So where is phosphate here? This is phosphate over here, so it's PO4 3 minus for phosphate. So PO4 3 minus. Potassium, we know the valency is 1. Phosphate, we know the valency is 3 because of that charge there. You swap them, so it's 3 and 1. You can't divide that, so it stays as 3 and 1. And in the end, it would be K3PO4. So we've now got an equation for it. Let's check that it's balanced. So let's rewrite it, including our new salt that we now know. Let's write down all of the elements that are present. So potassium, oxygen, hydrogen, and phosphorus are present. Now we have 1 potassium on that side. We have 3 on this side, so we already know it's not balanced. We've got 1, 2, 3, 4, 5 oxygens on this side, and we've got 5 on that side. Yeah. We have 1, 2, 3, 4 hydrogens on that side, and we only have 2 on that side. And we have 1 phosphorus on this side and 1 on that side. So some of these are balanced, some of these are not. Okay. Now the first step, we're to work our way down. Our potassium, we have 1 on this left side and 3 on that side, so we're going to need to put a 3 in front of this because that's the only compound that has potassium in it, and we need 3 more of it. That changes that to be a 3. It also changes our values for oxygen and for our hydrogen though. So we now have 1, 2, 3, 4, 5, 6, 7 oxygens, and we have 1, 2, 3, 4, 5, 6 hydrogens, and it didn't change our phosphorus. So our potassiums are now balanced, our phosphorus are balanced, but our oxygen and our hydrogen are not balanced. So what we need to do is we need that to go from 5 to 7 for our oxygen, but we don't want it to affect our phosphorus. So what can we do? If we wanted 7, we could put a 3 in front of there. That would give us 1, 2, 3, 4, 5, 6, 7 oxygens there. But it would also affect our hydrogen. We'd have 6 on this side now, which is exactly the same as that side. So it solved both of our problems. So that is now balanced. You need a 3 in front of your potassium hydroxide and a 3 in front of your water. So now that we've got our balanced equation, our step 2 is our titration. I'm going to rewrite our balanced equation out. And make sure that you've written that out correctly. Just just saying. And we're going to do exactly what we did before with our C1, V1, N1, C2, V2, N2. Exactly as we have done for all of the previous examples. Okay, so if you're feeling confident with this and you know, and you think you know how to do it, what I would encourage you to do is skip ahead just now and try this for yourself, or pause it and try it for yourself, and then skip ahead or play the answer after, just so that when you go on to do questions by yourself, it is not diving at the deep end completely unknown. So I would suggest that you try this one without looking at it, and then watch as I go through how to do it. So we are going to write down all the values that we know from the question. Let's see what it tells us about our potassium hydroxide. So our blue is talking about KOH. What do we know about that? We know the concentration is 0.05, and that's all it's given us. So 0.05. We know also our N from here is 3 this time. We've not had a 3 yet, but it's asking us for the volume in the question because we don't know that. Our acid is our phosphoric acid there. So let's find out what we know from the question about that. So we know the volume is 17.1, and we know the number, not the number of moles, the concentration is 0.25. So that would be 0.25 and 17.1 for them there. And we can figure out the N using our equation. Our N2 is actually 1. And all we have to do now, just like before, is put these numbers into our lovely equation there. So we know that C1 is 0.05. We don't know what V1 is, and we do know what N1 is. Our C2 is 0.25 times 17.1, all divided by 1. So all of that side together, if you do 17.1 times 0.25 divided by 1, should give you 4.275. And I'll just rewrite this out as it is. Let's do one thing at a time. Okay, so if we want to figure out our V1, what I would recommend you do first is you do 0.05 times V1 equals, and then figure out, it would be your 4.275 times by 3, okay, that should be in black, which would equal, if you plug that into your calculator, should equal 12.825, but that's still 0.05 times V1. V1 would be your 12.825 divided by your 0.05. Which in the end should give you 256.5 centimeters cubed. So that is 5 examples of how to do these questions. Okay, what we are going to do is we're going to set you some more examples to practice yourself, and I am also going to upload this to Teams, so all of these questions and answers will be available for you to have a look at and to work through. Watch this video while you are doing your ones as well, if it helps, and have a go at them. If you have any questions, please ask on the team, please email anyone, we don't care, as long as you're asking for help when you need it. Okay, that's all from me. I hope this has been useful as a little bit of a follow along video to help you understand titration calculations a little bit easier.